Hello friends, welcome back to Max Lecture Series. So in this lesson, we are going to learn how to obtain the answer for the various functions under vector integral. We might be heard in vector integral, sometimes we will be integrating the functions directly, sometimes we will be integrating the functions by using Green's theorem, sometimes we will be integrating the functions by using Stokes theorem, sometimes we will be integrating the function by using divergence theorem. Now let us see all those things, let us understand all those things directly through problems. Now if you observe the first question here, the given question is value of the integral, closed integral xy into dy minus y square into dx, where c is the square cut from the first quadrant. C is the square cut from first quadrant by the line x equal to 1 and y equal to 1 will be. In bracket they told use Green's theorem to change the line integral into double integral. What they are telling is, in order to get the answer easily, if we use Green's theorem, then we can easily convert this function. Given it is single integral, right? If you observe only one integral is given, we can convert it into double integral from the given data. After that, it is very easy for us to bring the answer. They are telling like that. Now, remember one thing, whether they are asking us to use the Green theorem or not, whenever you are observing separately, some function will be given with the dy and some function will be given with the dx separately. Whenever a function will be given like this with a single integration, always my suggestion, just to try to go with the Green's theorem. Most of the time you will be getting the answer. Let us try what will happen here. Let me teach you first what is Green's theorem, how to apply or how to write down the Green's theorem. Now we are going to write down the solution for this given function. The solution is going to be, if you observe, sir, what is Green's theorem and how to use Green's theorem. Green's theorem basically helping us to convert line integral into surface integral, that is single line integral into double integral. How will you do that, sir? Basically, if you observe the standard form of Green's theorem, it will be represented as m times of dx plus n times of dy, whereas m is some function with the dx, n is a function with respect with the dy, that's all. It can be converted into double integral form. Just observe here, in the double integral form it can be written as dou n by dou x minus dou m by dou y, I am closing the bracket, into we can write dx dy, that's all. It's very simple. Now if we observe our function, see there, let me take our function one more time and I will be rewriting it here. Just observe how I am doing this. That is very simple actually. Our given function is closed integral of, so what they given here, I am just interchanging the position, right? See there, here I have written dx first, dy second. So I am writing our given expression also in the same format. So minus y square into dx plus the second form is going to be, second one is xy into dy. Okay sir, this is the given. Now what we have to do, we are going to convert it into double integral format. Just a double integral of, in bracket, let us observe. See, if you observe here, I wrote n, I wrote m. M is there with the x, n is there with the dy, that is m is there with the dx, n is there with the dy. If you compare this with the standard expression, from this I can say value of m can be written as minus y square, and from here I can say value of n can be written as x into y. After that what we need? We need dou n by dou x. Dou n by dou x means we have to differentiate n with respect to x. If we do that, we will be getting y. Similarly, we have to differentiate m with respect to y. See there, dou m by dou y. If we differentiate this function with respect to y, this will be giving us minus 2y. Let us substitute both value. Dou n by dou x, we got y minus of, see in the formula we have a minus. Here we got the expression, see what we got for n, m equal to minus y square. So from that we got minus 2y. So let me substitute that minus 2y also here, such that the overall value will become 3 times of y. After that we can complete our integration. So y minus 2y, y minus of minus 2y will become double integration of 3 times of y into dx dy. So everything is fine. After that, it times to identify the integration limits from the given data. Go back to the question. They have given some other data. See, where they told where c. This is c will be helping us to identify the limit actually. Where c is the square cut from the first quadrant. Square cut in the first quadrant by the line of x equal to 1 and y equal to 1. They are telling. See. Let me draw. If you observe first quadrant, in the sense we know positive x is positive x, positive y. This is first quadrant. In the first quadrant they are considering two lines. One is x equal to 1 line, another one is y equal to 1 line. So what they told, there are two lines, one is y equal to 1, another one is x equal to 1, and they are going to be, see there, the first quadrant is having a square cut. Square cut means we will be having a line like this, x equal to 1, y equal to 1. They will be cutting each other and they are having a first quadrant square cut line. So here it will be 0, 0, we all know, and see there, here what we are going to do, we are going to consider up to, if you observe 1, 1. So here what is the value we will be going to consider? 1, 1, 1, 1. So in the x-axis we will be traveling from 0, 0 to here the value of x is 1, value of y is 0. At this point value of x equal to 0, value of y equal to 1. So this is what given data. Now what we are going to do is, from this square cut we are going to directly take the integration limits, that's all. If you observe the x limit in the square cut, x is traveling from 0 to 1, maximum value of x. Similarly, if you observe y also started from 0 and it is ending at y equal to 1. I am repeating, nothing they told, they asked us to take the first quadrant. After that, see there, in the first quadrant draw a line. So in that line, one line is x equal to 1 line, another one is y equal to 1 line. So take y equal to 1 point, draw a straight line in the first quadrant, x equal to 1 point, draw a straight line. After that, they only told that those two lines are going to be cut each other such that they are forming a square. So according to the given data, I have just drawn the diagram. From that I observed that x is varying from 0 to 1, y also varying from 0 to 1 only. There are no more things to observe. Only very few cases they will be giving like this. In some cases what they will give is directly they will be giving the limits. Anyway, when they are giving the data in terms of diagram, it is very important to observe. Don't worry, by solving more number of questions, automatically it will become very easy. Fine, sir. Now hereafter, we know in double integration, whenever function is not there in the limit, function is not there means when you are having finite values in the limit, either you can integrate the function with respect to x first, or you can integrate the function with respect to y first. Choice will become yours, because we are having what? We are not having any variable in the integration. We are having some values 0 to 1, 0 to 10. It is not like we have to keep only finite value. You can keep any value, but if you are not having any variable, like here we are going to integrate this function with respect to x and y. So in your integration limits, if x and y are not there, only values are given like 0 to 1, 0 to 10, 0 to 100, 0 to infinity, minus infinity to 0, whatever it is. When variable is not there, when integration variables, here we are going to integrate with respect to x and y. When this x and y functions are not there in the limit, then you can do the integration with respect to any one. Choice is yours. Let us do it. First, I am going to integrate the function with respect to x. Since there is no x in the given function, so directly dx will become x and the limits are going to be 0 to 1. Still one more limit is pending. From here I can say, see, upper limit is 1, lower limit will become 0 for the x. So 1 minus 0 will become 1 only. So simply we will be having 3y into dy, and the limit is going from 0 to 1. After that, what will be the final step? The final answer is going to be 3 into y will become y square upon 2. Since the upper limit is 1, lower limit will become 0. So 1 minus 0 once again will become simply 1 by 2 We have one more 3. So, the correct answer is 3 by 2 for the given function. This is how we are effectively applying the Green's theorem. Just mark it. You have to remember this formula, that is enough. Whenever they are asking Green's theorem, directly write down this formula, or whenever you are observing the function in this format, like m into dx, some function into dx, some function into dy with a single integration. Directly you can apply Green's theorem, you can convert it into double integration, you can easily bring the answer for the given function. I hope you all understand Green's theorem in this lecture. Rest of things we will see in the next class. Thank you all.